printer. Okay, so uh, sorry, Hong, do you want to make any announcements before class or after? Yeah. No? Okay. Uh, I just asked maybe you have anything. Okay, so as I said, we will talk about recursion, and the first problem that we will do, we will draw this tree, but reusing only one function instead of creating like several different functions for level 2, for level 3, for level 5. So let's start coding PyCharm. New project. Week 3, section 5. So just to recall, so it created like starting file by default. I just want to recall, what do you remember? What does this if the name equals main mean? And do we need this in our actually main file? Yes.
It checks if the code is being executed from the main file.
From the file with from module file is module with name main or with other name. So the executing file at this time, at this moment, always has the module has name underscore main. But if I would import something from another file, the functions from that file would have another name. But do we need this in our main file? Do we need this statement to make? No. I mean, it creates by default because it's the standard. You couldn't run code without main in Python 2. But in Python 3, you don't need this statement, and we can just read off this statement. But I can just illustrate if we for example, for homework submission, uh, we ask you to comment all the code or delete it. But another way to run your functions, you can just use this if statement and here call your functions and do not delete this after submission, because when we will read your file, all the functions from your file will have name of the name of your file. It won't be main, so it won't be running. Does it make sense? So because maybe last time I showed the example, if I create another file here, let's see, new file, Python test, and create here a function, my function, and for example, I will print here something. then and call this function in this file. My function. Then when I will import this file in my other file, I will import this function and I can call this function here, but if I don't call this function, it still will print, it will execute this function, even though I don't call this function in my main file. So if I add here if statement, and now run my main file, you will see that it won't print anything which was after this statement. Bless you. And just to show what is going on under the hood, I can print, for example, print hi is the function in our main file dot module, and I can print the function that I imported from test file, which had name my function dot module. And you will see that the module name for function in my file is main, but the module for function imported from test file is different. It has the name of the file, and that's why any code after this statement won't be running, because the name for this function is test, not main. Okay, I just wanted to repeat it. Yep.
Is this only within a project? Like you can import things within a project and like not outside of their projects?
Oh, so it works with any file. So when we do import, so it will import all the functions from file test, from arbitrary file test. But if this file contains some code like print or function execution, then it will also run this code. But if in the test file, the code which is running, you put after this if statement, then it won't be running. So it works with arbitrary files. Just so, yeah, we need this only when we work with multiple files. For now, I believe up to maybe week 6, so we won't use multiple files. But I just want to show that you can use the prints or calls of your functions in Homebrook submissions. Just add this if statement. Otherwise, you should comment everything. Okay. Now let's create the function tree and draw the tree. New file. Let's call it tree. Import total st. Our function will take argument size, and we will draw a line of this size, and we will go back. So let's call this function. Oh, I didn't name this function. Draw. and call this function. Draw tree of size, let's say 100, and keep this screen open, turtle.done. So here I will change to run current file. By default, it will run file with name main. And it draws the one branch of the tree. What should I also change? Maybe the starting position, the the initialization. So let's rotate left by 90 degrees. Okay. Now I want to draw the, when I go up, I will call my function without any changes. I don't think it will work. Let's see, but then we will adjust the function. So I will rotate by 45 degrees and call my function again. Draw tree with twice smaller size. I believe we will get infinite loop, but let's see. Okay, it's working, but it's kind of infinite. There is infinite loop because we don't have like stopping condition. So let's add here parameter level of the tree, and I will create the stopping condition if level is 0, do nothing. If level is 0, pass. Otherwise, I will do this code, and I use tab to shift all this code to make this like aligned. And now I should call my function with also additional argument level, and I subtract 1. So to reach 0 at some point. Otherwise, we never will stop. Okay, so, and I will call my tree, but with also additional parameter, let's say 2. Okay. I didn't rotate my turtle back by 45 degrees, so that's why I will have this line. Let's rotate it back. Turtle dot right by 45. And now I can use more levels. So instead of writing several functions, different functions for each level, I will reuse this function, for example, for level 5. So let's take a closer look what is going on here. So when I call my function with level 5, first I check this condition. It's false, so I go to else branch. In else, I do forward by the size, then left by 45, But then I call my function again. I call my function now with level 4 and size twice smaller. So we enter this function, check this condition, it's false, so we go to else, and we go forward, but now by twice smaller size. What's going on after that? After that, we rotate by 45 degrees and call our function again. So we start our function from the beginning. We check condition level, it will be 3 at this point. We do forward, but now it will be sized by 4, because by 2 and by 2 on the next step. Rotate by 45 and call our function again with parameters level 2 and size twice smaller. And finally, we will reach this value 0. At this, when we reach level 0, we will do nothing. We'll just rotate by 45 degrees and rotate back by 45 degrees. Okay, yep.
So basically just like calling it over and over and it's like in a loop.
Yes. So we're using our function, but at some point we should have a condition where to go back. So how should I change this code to have the right hand branches? Right inside branch. So it's somewhere I should call this function draw tree, but from the right. Yeah.
You first of all, you would want to change your turn right functions.
Yeah, by
turns by 90.
90, correct, because we want to move by 90, and then
And call the function as you did
Yep.
inside
Yep.
again.
just copy paste this call, and after that I want to rotate turtle back by 45 degrees left. Let's see. Yeah, it's working. If you want to increase the speed, you can call turtle speed 0. It's the maximum speed. If you want to hide the turtle from the screen, this triangle, then there is method hide turtle. And let's increase the level by 10 or 9. And here's the tree with more branches. So next problem for today is, while it's drawing, to draw, this is an example, I just put this link to this blog page where people draw different things with turtle. So for example, if you change the angle when it's going to the right and to the left, if you will use different a little bit angles, so you will get this kind of curved tree shape. But now we will draw this figure, square with squares on the corners. So let's first check our tree. Okay, this is done. So to draw this square, first I will draw familiar function from lab 1 block. which draws just a square. New file squares import total st. Define function draw squares. Again, I will use parameter level. I won't use this just for drawing one block, but I will use it later. And the size of the side. And I will include the statement for level 0 just to have it if, or maybe I will include it later. Just for now, let's draw the square forward by size, left by 90, and I copy this 4 times. And call this function. Okay, here is the square. Now I want to draw squares on the top. How can I reuse my function, which draws the block, to draw, for example, this block? Where should I place my, or where should I stop my torso on the halfway? So my torso goes forward, then left, and then forward. I should stop it here, but how should it be faced? Because when it goes up, it will be faced north. But if I want to reuse exactly the same function, it should be faced this way. Does it make sense?
Why?
Huh?
Why does it have to be placed that way?
Oh, because for now I have turtle which draws one square and it's facing east.
Oh.
So if I want to reuse exactly the same function, the starting orientation of the turtle should be also facing this right direction. So after 2 forwards, I will call my function again. Like on the halfway. And I will now include this level 0 condition also. If level is 0, do nothing. Otherwise, so intend this. After 2 forwards, so first forward, second forward, instead of rotating by 90 degrees left, I will rotate my turtle by 90 degrees right. And call my function again, draw square with level by 1 less and size twice smaller. Oh, I didn't rotate the turtle. So after turtle finishes drawing first square, I should rotate it by 180 degrees back. So I should add here left, right, it doesn't matter, it's 180. Okay, it looks better. How to, because my level was 2, so that's why it drew only 2 squares. Now, how to draw the left square? Where I should position my total for this? And call the function again. So it should be somewhere here, like when I move from this point to this corner by size, I can change it and move by 1.5 times size. Like size and half size. Does it make sense? Okay, let's add this change and call our function again. So after drawing here, I will move by 1.5 times size. Rotate like to face it east, rotate by 180 degrees. And call my function draw squares with twice smaller size. But after that, I will need also to move my turtle. But after that, I will need to move my turtle to this corner, half size back and down. So I will need, after that, move turtle forward by size over 2 and rotate by right. To right. Oh, I did something wrong. Maybe. Oh, because I see. I wrote, okay, it was correct, rotate by 90, but I should read off this line, left 90. Okay. And let's do maybe more levels. So it looks almost there, but we have problem with like the last level blocks. So how can we, so first of all, why do we have extra line here? Do you remember from this point we moved by 1.5 size and call our function again. But if the level is 0, there is statement pass, so it doesn't do anything. So we go back to this point and go down. So it happens is only on the level 1. So maybe we can do if statement, and in if statement check if level is 1. If level is equal to 1 or not equal to 1, let's do this, not equal to 1. We move by, okay, equal. If it's 1, we will move forward by size instead of 1.5 size. Else, we will move by size. Let's see if it's fixed the problem. So it fixed the problem with the length of these bars, but we we have another problem now with when turtle goes back by half size, so I will add also if statement there. So when my total goes back here by half size, I will do this only if level is greater than 1. And this fixes the problem. Okay, so what is the standard function which is used as an example for recursion? So every time that people talk about recursion, which function they are using? Yeah, for loop function, like mathematical function. Yeah,
Fibonacci?
Fibonacci, but easier. Factorial. Factorial, yes. So let's do first Fibonacci and then factorial. So let's see if oh no, wait a second. First, this is problem for you, and then we will go to fruitful functions. So could you use the same idea, the function that takes two arguments, level and radius, draw these circles inside circles. And the second problem will be to draw these circles, but with changing colors. So for this example, I used radius divided by 1.5. You can use also divided by 2, but then you will have like more spaces between these circles. And please, who will write this function, just come here and we will project your screen on the whiteboard, on the projector, on the screen. So everybody will see the code. So just who is ready first, just come here and project your screen. Okay, so here is just example how this function was working. There we go. Oh, then come and connect your machine to this USB-C, I believe. And share USB-C. And could you enlarge the font? So if you go, oh, it works. Wait. Oh, and could you divide by 1.5? Because 2 will be 2, they will be very small.
You'd have to turn on speed too.
No, it's fine. So you see that these you could use turtle down
After the function?
after calling the function.
Oh, yes.
So because our original position of the torso it's facing east, when it draws circle, it's still facing east, so we don't need to change the orientation. Just call this the same function with smaller radius. So could you think now about changing the colors? So if we want to get like blue circle, then red, then blue, then red, how can we change this function to alternate the colors?
Should I say?
Yeah,
Oh, you could do if the level is even, then it's red, it's odd.
yeah, it's a good idea. So we can look at the remainder of the division by 2. If this remainder is 0, then we can use color blue. If this remainder is 1, we can use color red. This is one solution. Did
You
you
put that-
did you get the
Yeah, would you put that inside the else statement, like right
Yeah,
before
you can
here?
you can do this inside the else statement. One more else if
Mhm.
if and reminder is the percentage. The other solution would be to create a new variable. So you could also introduce another variable here, color, and then in the statement check if color is blue, if color, then color
Mhm.
equals to red.
Switch to red.
But this solution with checking if level is even or
What set color?
is easier.
I forgot what set color was.
Oh,
Back fill color.
no, fill color will fill a shape, just color.
Just color.
Yeah. Or total color or pen color, but color is else just else.
Oh, just else.
Let's run it.
Yeah.
Oh, you.
Oh, you gotta, no, the set one. First one isn't set because,
Oh, okay, because you didn't set the first one. Okay. Yeah, but it works. Do you want to set
the first one.
Uh, like in the beginning?
Yeah.
You can just move the if statement above the circle.
Oh, you're right.
Move this here.
Yeah, just move it up where the color.
Yeah, that's a great idea. Well, and I wanted to have blue, red, so just you would change your statement, but instead of no, yeah, you could change here, but you could also change just 0 by 1.
Yeah.
But it's fine. At least yeah, that's the idea. Okay. Thank you. And now we're good to go to factorial. So let's see. Factorial is the product of all previous integers. By definition, we set factorial 0 to 1. And let's write this. Yeah, why we can use recursion? Because, for example, factorial of 3 is the same as 3 multiplied by the product of 1 and 2, which is factorial of 2. So here is this call of our function with argument by 1 less. So we use n times our function of n minus 1. So factorial. The first code without importing turtle. The fine factorial of n. And if our n is 0, we will return 1. Otherwise, we will multiply n by factorial of n minus 1. Else return n times our function factorial of n minus 1. And I will read n. I will cast string into integer. And print the value, print. So you can think about what is the factorial of 3, 6, because it's 1 by 2 by 3. We will check this now with our code. Okay. I will use formatted string. So factorial of n equals to n. Factorial of 3. Okay, something is wrong. Oh, I should return factorial of n. Okay, because of course n equals n. Okay, now factorial. Go away. Factorial of 3 is 6. Just one. So let's look at what is going on under the hood. So I will run now this code line by line. N equals 3. So first my program goes and it sees that it should evaluate function fact of 3. Then it goes inside this function, inside of function fact. And it checks these statements. If this statement is false, so because n is 3 now, it will go to the next line. In this line, it says that 3 should be multiplied by the call of this function of 2. You can see here, this is called this execution stack, that it created another copy of function factorial with n value equals 2. In the previous function, n equals 3. In this call, it equals 2. And it goes inside our function again, but with value n 2. Again, it checks if n is 0. It's not. It goes to this statement. In this statement, it sees that it should be 2 multiplied by factorial of 1. So it creates another copy of function factorial with n equals 1. And again, it checks the statement. If n is 0, it's not. It goes to this statement, and it says here that n1 should be multiplied by a factorial of 0. It enters, creates another function with factorial with n0. And finally, the first statement is satisfied. In this statement, n is 0, it just returns 1, and this is very important. Here, it doesn't call itself. That's why it will stop here. In this line, the function called itself. But in this line, it just returns a constant value. And we're done. Now, we go back and instead of factorial of 0, we will use this value 1. So you will see now that from this function, we will go on the previous level. So it returns 1, and we go to the previous level. On the previous level, n was 1. It says that we should return 1 times factorial of 0, which is 1. And now we go to the previous level. Now n is 2, so it will be 2 times the result evaluated on the previous step. And you see how this execution stack empties now. So the last level n equals 2, and factorial calculated on the previous step was sorry, n3, and factorial calculate of 2 was 2. And we're done. So this is called execution stack, and we can write execution trace. So for factorial of 3, we have 3 multiplied by factorial of 2. But then we should call this function with variable with value 2. So that's why now we kind of forget about 3 and only work with factorial of 2, which is 2 times factorial of 1. Then we forget about 3 and 2 and work with function factorial of 1, which is 1 by factorial of 0. Finally, factorial of 0 returns us as 1. And we go in backward direction. We evaluate factorial of 0, then we multiply with 1. Then this result we multiply with 2, and finally this result we multiply with 3. So it's kind of forward path, and then we go backwards. How many steps will program do for factorial of n? How many copies of function it will create? N times 2, because it creates n copies, but it goes like backward, forward and backwards. N times 2. So the time complexity will be linear. It's proportional to n. Okay, let's do a break now, and then we will go to Fibonacci and other problems with another time complexity.
Let's go a bit late for the Tetris pieces.
Yeah.
That's the bottom.
The coordinates of
Down.
the boards of this. And here's the example of how it is.
That's just on the outside side.
Yes, and don't worry if the shape will fall like outside the board. It's fine for this phone, for this laptop.
How would I analyze a conference like cities? How would I, in general, analyze the conference?
In general, well, in general, you should understand the time complexity of each step. So,
I don't know.
in case of factorial, on each step, we do just one operation, multiplication. So that's why it's easy to understand that we do like n operations reach the smallest value of n, and then we will do n operation just to multiply them. But in general,
Figure it out, I think.
I would say they're just main functions like for loops. So for example, if we have one for loop, the time complexity will be or it's not function. It's so in general, if you have function of n, which equals a function of n minus one,
It's also just, like, it's what it was called last year.
you can just
It's probably
I
gonna
don't
use the
remember
same
what is the term for this, but just open these functions using n minus 2, n minus 3,
because it's an actual.
and when you reach 0, you will understand how many steps it took. But there are other functions like in general it's you can solve this is called difference equations. So there are formulas for solve difference equations, but typically in course of algorithms, class algorithms is about compression. We just consider some constructions like forms or other algorithms and analyze the complexity of this algorithms. There is no, I believe, like general formula, yes.
Bottom, middle, top.
So do you have a question?
You said middle.
No.
Middle top. Is it behind me? It's your fault.
Yeah, no.
Sorry, is it Evan's side? Okay.
Yeah.
Okay. Oh, it's in regarding the
Little
wall.
like,
For some reason, it just reached the back.
No, I was the one that typed it. Yeah, I saw it written. I don't know what happened.
No, oh no, it's a debugger. So it appears only if I click on this bug, on this bug. It's called debugger. So if I call debugger, oh, wait a second, I'm in the wrong. It's here. It will. So let's stop. And run again. Yeah, you don't need and here.
Okay.
Okay, that's, I've deleted it and it's working now.
Yeah. So when you run in debugger mode, it just shows the value of the current variable. Let's see, but it doesn't work.
See, decoder.
Oh, maybe. Yeah, let's see. For some reason. Wait, it's not working.
Okay. Yeah. Thank you.
Oh, it's working here. Yeah, just in this mode, it's in different color. The value of variable.
Professor, I have an issue with the homework. The auto grader took points off for questions that weren't number one.
It's the same thing.
Like for the turtle. So I got like 6 points taken off. Was that supposed to happen, or is it like a glitch that I should email something else about, or?
Well, this is auto grader. It's
Yeah, but there's like a ton of points for like the question twos and the question threes. And but I passed all the question ones, which is what I thought should be auto graded.
yeah, but what about question 3? It should be also auto graded. That's second.
No, it was, the limit did exist.
Yeah, it's like down here.
And then we got all right on lesson 1 too.
Yeah.
But it's still.
The two did exist, I think two was like three, and the four was yeah. And then continue on, yeah, and there it's a. Or.
Question 3 is partially auto graded, so
Alright, I think I did well. I think I did it all right, except for maybe some.
because it returns false and or true. Does it return the duty of the code?
Yeah.
No, I mean you can show the
Oh,
code.
oh, yeah.
Even here.
But she swam to our homework, and the last thing was.
Yeah, you have return statements.
I gave.
But it looks it didn't pass some tests. It's weird. Question 1 passed all tests. But what about question?
Well, yeah, maybe these points, but.
Oh, yeah, you can see some tests are passed and some are not. So that's why you don't have to delete.
Oh, what does this mean? Like it says you have one the same because it was turtle.
So the question 3 is partially graded, like auto graded, this true false, and partially it's graded by pen, just looking at the shapes.
So is there anything I can do about it, or am I kind of out of luck?
Oh, no, I mean, they want to see the like correct answer. Oh.
Well, I was more just curious if I can get those points back, or like, because if I can't, I mean, it is what it is, like.
No, I mean, if this function would work correctly, you would pass. So it means that
There's something.
It also says like
no, question 2 is not auto-graded. But you have 0 for test for question 3, some tests. So I believe this is the problem.
Right.
So it means that it didn't pass some tests on the nice shape, nice.
Draw a good rectangle.
Something like that. Perfect.
Alright.
Yeah, because if function returns stuff, we can do auto grading.
Alright.
And the result spells false.
Oh my goodness. I mean, I have maybe. What I'm thinking is maybe. Maybe it's because I don't have a return false. Maybe I need a return true. And then of my.
Oh, yeah.
That is what it is.
Yeah.
So. All right.
Yeah.
No, I know for the future. Well, you failed different tests than mine, because my tests were the ones that threw something, like the ones that didn't. I passed those ones, I didn't pass the ones
Yeah,
that,
it's like
so it probably is just that one.
because you didn't use.
Yeah.
You're welcome.
So, now that we have, it's working. How big is it?
Print. Oh, you can add also print, like here print factorial of them.
So we are printing.
You don't need to print everything. You can print just factorial of them.
So why did you put that? No, like why did you put the first part? This first factorial thing.
This is how this formatted string works. If you add f, you can put the variable in the brackets, and it will print the value of this n. Like here, you can see it prints fact, and instead of n, it prints its value.
Instead of being in a string.
What?
You understand?
Instead of being in a string.
Yeah, but if you just want to see the value, you can just print factorial of n.
Okay, so that this prints like what we are seeing the factorial of.
This one.
So this is the number, and then this print the factorial of this number.
Yes. I mean,
Why are you asking me?
no. Well, just type print from the beginning of the line. Print. This name of n. And that's it.
So
Yeah.
I'm supposed to assign the value.
So you can rerun or stop. Type the number. Yeah.
And enter.
Mhm. And this is the factorial of this. Does it make sense? So here you input your n, and here you call your function to calculate. So what questions do you have?
Yes.
I don't know how to fix it.
Okay, no problem.
I think
I missed something like after the if statement. I don't know what you put after that. And it mine comes out the same as the producer. If not.
Okay, you can take a look here. So
Okay.
draw square. Then it goes left.
okay,
No.
And then is this one supposed to be after it, or did you just remove?
That's what I have.
let's see.
Okay. That's not right.
Okay, it works.
Is that what it was supposed to be?
If you increase the number of levels, it will be more. Okay, now you can take a look at her code.
Okay.
Okay. So
I know that. Yeah.
Yeah, I got 3 points for that.
Also.
Yeah, you get 3 points. That's why I love doing this. You're missing your own.
To me.
Yeah, I don't have all of it.
See, that's. Calculator doesn't make sense when you go.
I already have that.
Oh.
It just.
Oh.
I think there's.
Okay, so let's talk about rabbits. So, Fibonacci numbers. Fibonacci was an Italian mathematician who lived in Florence somewhere in 16th century, and so he wanted to ask the question: how many rabbits we will have if we have just one pair after several months? So his assumption was that on the first month, the rabbits are still small to produce, and they can produce a new pair only on the second month. So let's see how it works. So the first month, we have a couple of pairs not pairs, of rabbits. Sorry, I'm thinking about food. The second month, we have this couple of pair rabbits. I don't know. So, and they grew up, so they can produce, and they produce another couple of rabbits. So what we have the couple of rabbits which we had on the previous month, plus a new couple of rabbits. What's going on the next month? The new couple of rabbits they're still small, they can produce. So we will have these two couples. But the first couple now is grown up and it can produce. So we will have these two couples plus one new couple produced by the parents. And you can see that now we have kind of 2 plus 1. On the next month, we have 3 couples. 2 couples which can produce, and 1 couple which is still small. So what happens is on the next month, we will have all these rabbits. So we will have 3 couples plus couples from the rabbits that can produce. So, and the rabbits that can produce, they are the same rabbits which were on the previous month. So we have 3 couples plus 2 new couples of rabbits. And if we continue this process, you can observe that every time we will have the same amount of couples of rabbits as in the previous month, plus new couples from the month before that. So the general formula I should have Um, the general formula for Fibonacci sequence is this one. Fibonacci of n is the sum of Fibonacci on the previous step and on the step before. So if we start from 0, then we sum up these numbers and we will get Fibonacci of 2. To calculate Fibonacci of 3, we should sum up Fibonacci of 2 and Fibonacci of 1. And let's just answer the question. What is Fibonacci of 5? Fibonacci of 5. To answer this question, we should sum up Fibonacci of 4 and Fibonacci of 3. So it will be Fibonacci of 4 and Fibonacci of 3. What is the value for Fibonacci of 3? 2. So this is 2. 1 second. I'm still writing. So this is 2. What is Fibonacci of 4? We should sum up Fibonacci of 3 and Fibonacci of 2. Yeah, you can speak out. 3, yes, because Fibonacci of 4 is the sum of Fibonacci of 3 and Fibonacci of 2. So 2 plus 1, it will be 3. So what will be the value of Fibonacci of 5? It will be 5. What will be the value of Fibonacci of 6? 8. Yeah, it will be Fibonacci of 5 plus Fibonacci of... I had this number on the previous slide. Here. Like every next number is the sum of 2 previous ones. 8, then 5 plus 8, 14. Here is the code. It's different from all the previous code that we had because it has 2 base cases. I didn't mention this statement when we checked the level is 0 or number for factorial is 0. We call this base case when we stop our recursion. So for Fibonacci, because to evaluate function, we need the function at 2 previous numbers. We should have 2 base cases. So let's code this function first, and then continue talking. We'll continue to talk about this. New file. A new file, Python file, Fibonacci. Define Fibonacci of n. So few words about notation. Why sometimes I'm using capital letters, sometimes lowercase letters. So let's say I want to call my function Fibonacci function, and I can type fib func. How is this style called? What is the name for style? Camel. When we call variables with capital letters, it's called camel style, like tips of the camel. We could use another style, fib and underscore func. How the other style is called? Do you know? It's called snake style. So by default in Python, by agreement, people are using snake style. So that's why always when I create variables, create functions, I'm using lowercase or underscores in my names. Only for classes, when we will talk about classes, we will use capital letters, camel style. So the two base cases, if n is 0, return 0. If n equals 1, Fibonacci of 1 is 1. Oops. I used extras phone. And otherwise, we return the Fibonacci of n minus 1 plus Fibonacci of n minus 2, the sum of two previous. And let's call this function n equals or input and print Fibonacci of n equals to Fibonacci of n. Okay. So do you remember Fibonacci of 5 was 5? Okay, it works. And Fibonacci of 6 should be 8. It works. Now, let's look closer at this function. When we calculate Fibonacci of 5, we should call Fibonacci of 4 and Fibonacci of 3. I won't write fib, I will just write the variables values. To calculate Fibonacci of 4, we should evaluate Fibonacci of 3 and 2. Oops. 3 and 2. To evaluate Fibonacci of 3, we should call the function of 2 and 1. 1 is the base case. So if n equals 1, we will get value. But to evaluate Fibonacci of 2, we still need to call our functions of 1 and 0. 2 also we should call from 1 and 0. 3 we should call from 2 and 1. 1 is base case, but 2 we should call 1 and 0. Let's count how many times we should call our function to calculate just the fifth Fibonacci number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Does it sound reasonable to calculate just fifth number, call the function 15 times? Well, we don't know for now better solution. We will talk about this next time, but for now, I just want you to think about the complexity, time complexity of this Fibonacci function. So you remember for factorial, it was linear, it was 2n. Here, for Fibonacci 5, it's 15. For Fibonacci of 8, it will be 67 calls. And we will talk later about this kind of tree complexity. It has exponential time. So for example, if we want to calculate factorial of 1000, we should do 2000 operations. If we want to calculate Fibonacci using our implementation of 1000, we will need to do about 2 power 1000 iterations, which is infeasible. It's just gigantic number. So I just wanted to bring this to your attention for now, and let's try to call Fibonacci, for example, of 30. It works, but of 60, I believe we will wait. Yeah, you can see. We should wait, and maybe for several months. So I will stop execution here. And why these functions works so differently? So why there's also package time. If we call import time, we can measure like the starting time and the time after execution of our function. And then take the difference and we will see the time of execution. So for example, for let's say 30, the time is about 11 milliseconds or 1/10 seconds. For factorial, if we do the same, if we run factorial of 30, it's less than 1 millisecond. We don't even see the time. So what do you think? Why the execution for Fibonacci time was 0.1 second, and for I partially answered this question talking about time complexity, but I want to hear like your understanding. What's the difference between these two functions, factorial and Fibonacci? You can think about how many times we call our function again in one case and in the other case. So factorial, it's n times factorial of n minus 1, and Fibonacci is Fibonacci of n minus 1 plus Fibonacci of n minus 2. Yes.
So you're calling it twice?
Yes. So the problem is that for factorial, we call once our function, and here we call it twice, but in each branch, it again calls itself. So that's the reason why we have much high complexity here. Okay. How much time do we have? I have two more problems. One problem is the division, and another problem is greatest common divider. Let's talk about division. If we divide one number by another number, we can look at this as we add the denominator several times plus the remainder, which is smaller than denominator. I hope you agree with that. So if we want to calculate the floor division, of course, there is a built-in function, but we can use recursion, and it will work as follows. On each step, we will just subtract one denominator. And how many times we subtract the denominator before we reach number smaller than denominator? It will be actually the multiple, the result of division. Does it make sense? Okay, I don't want to call this function. Let's just look at the execution trace. So two numbers, 8 and 3. How much 8 divided by 3? 2 and 2/3. So the result should be 2. Oh, sorry. There is a mistake in this slide. So first, I subtract from 8 3, and I will get 5, and I will add 1 because it's the first subtraction. Then I will subtract 3 from 5. And here it should look as follows. So this parenthesis is the call of my function divide of 5 and 3. And then I can subtract 3 from 2 because it will return 0. So here is a misprint. So disregard this one. So it should be 0 plus this 2. Or maybe 1 plus 1. Does make sense? Okay. The next function is greatest common divisor. If we have one number and another number, and we know that they both divisible by number q, it means that they can be represented as some number times q, and here some number times q. The nice thing about which is called Euclidean algorithm is that if we look at the difference of these numbers, it will be also divisible by q. And the idea is, instead of looking for divisor of two large numbers, subtract one number from another number. So 18 minus 15, we will get 3. And looking for the divisor of the smaller numbers. So this is the idea. Then you can subtract from 15 3, it will be 12. We call our function of 3 and 12. Then subtract from 12 3. And the algorithm, I will just write maybe here. I didn't want to type this, but we can. While I'm creating a new file, I will just I want just to comment the name of this algorithm. We don't know who was Euclides. We don't know if he even existed. But every textbook cites and attributes this algorithm to Euclid. So how do you know if we have any books from like first century, first yeah, from example, first century before Christ or from the first century after Christ? Do you know what is the earliest book that we have? Yeah. Sorry?
Elements?
What? Elements?
Yeah.
Well, but I mean, do we have like a real copy of this book, or we have this book copied during medieval age. Yes. And that's why it's hard to attribute this algorithm to Euclidus. Maybe we should attribute this to a monarch who wrote and put just the name of Euclidus on it. So, because what every history textbook says, we don't have the originals because they were all in the library in Alexandria, and this library was burned. But does it sound reasonable that all the books on the world were just in one place, in one library, and this library for some reason was burnt, and we don't have any books from this time? For me, it sounds like a bullshit. But every history book says this bullshit. So I wouldn't attribute this algorithm to some Euclidus, but just because it has this name, we will call this Euclidean algorithm. Okay, so and it's an interesting question actually, how many real texts survive from like this ancient times. People say that there are some papyruses, but there's just few pages, and still they should go through carbon dating analysis. And it's another question if they pass this analysis or not. Okay, so a new file, greatest common divider. Define GCD of two numbers, A, B, colon. Base case. This algorithm, Euclidean algorithm, will stop when we subtract like 3 minus 3, and we will get 0. So the base case is if A equals 0, and then we return B. And another base case, L, if B is 0, we will return A. And return. Otherwise, we will call our function, but we will subtract A from B or B from A, depending which is greater. Else, and here I will check if A is greater than B, I will return GCD of A minus B and B. Otherwise, I will return GCD of A and B minus A. Okay, let's check it. For example, print GCD of 12 and 15, it should be free. Okay, it works. Okay, I think now it's time for the quiz. And we know who created quiz. It's not Euclidus. It's Tony who teaches the section, I don't remember, 1, maybe. And a nice thing for you guys, the quizzes are opened for unlimited attempts till the end of the day. So the password for quiz is base case recurse.